Children, let's see how the bond line representation for different compounds are. Now look at the first one, 2-pentene. So the structure is CH3, CH double bond, CH, CH2, CH3. Now how to draw the bond line representation for this structure? Now how many carbon is there? You have to count first. 1, 2, 3, 4, 5. And how many bonds are there between the carbon? There is a bond here, 1, then 2, 3, 4. So these 4 bonds you have to show by zigzag manner. So 1, 2, 3, 4. Now after the second carbon there is a double bond. So 1, 2. After the second carbon there is a double bond. So put double bond between second and third. So this is how we represent the structure for 2-pentene. Now look at the next one, 2-methyl-hex-1-ene. Now here how many bonds are there between the carbon? 1, 2, 3, 4. So 4 bonds you have to put. 1, 2, 3, 4. And after the first carbon there is a double bond. Put the double bond. And on the third carbon there is CH3. So 1, 2, 3. Third carbon put the CH3. CH3 single bond represent CH3 group, because this is a bond which is between these two carbon, and it is understood hydrogen necessary is there on that carbon. So this is how we represent 2-methyl-hexane. Now look at the next one, 2-pentanol. Here OH group is coming on the second carbon, and how many bonds are there? 1, 2, 3, 4. Again 4. 1, 2, 3, 4. Now on the second carbon you can see there is OH group. So put a bond, but you have to show OH here. Okay. So OH has been represented. Other carbon atom, it is satisfied with hydrogen, and that's how 2-pentanol is represented. Now let us see how to convert bond line into structure, chemical structure, structural formula. For here, each bond represent carbon. So this one bond represent 2 carbon. So count and see how many carbon is there. 1, 2, 3, 4, 5, 6 carbon in a chain. So put the 6 carbon in a chain. 1, 2, 3, 4, 5, 6 carbon. And then 1, 2, 3. After the third carbon there is a side chain. 1, 2, 3. There is a side chain which is a carbon. Then 4th carbon and 5th there is a double bond. 4th and 5th there is a double bond. So this is how the skeleton is. Now put the necessary hydrogen. 1 bond is there, so put 3 more hydrogen. 2 bond already there, put 2 more hydrogen. 1, 2, 3 bonds are already there, so put only 1 hydrogen. This carbon has 1 bond, so 3 more hydrogen. 1, 2, 3 bonds are there, give 1 more hydrogen. 1, 2, 3 bonds, so 1 more hydrogen here. And the last only 1 bond is there, give 3 more hydrogen. We know that carbon satisfies 4 valencies, tetravalencies, so 4 bonds should be there. So that's why we gave the necessary hydrogen to satisfy tetravalency. Now look at the second structure. Count the carbon. 1, 2, 3, 4, 5. 5 carbon is there. So put the 5 carbon in a chain. 1, 2, 3, 4, 5. And now the last carbon is having double bond O and an OH group on it. So that's all you have to give there. And now give the necessary hydrogen to satisfy tetravalency. 1 bond is there, give 3 more hydrogen. 1, 2, so give 2 more hydrogen. 1, 2 bond is here, so 2 more hydrogen. 1, 2, so here again 2 more hydrogen. So this is the compound pentanoic acid. Okay. Now next one, count the carbon. 1, 2, 3, 4, 5, 6, 7. So put the carbon in a chain. 1, 2, 3, 4, 5, 6, 7 carbon in a chain. And on the 1, 2, 3, 4th carbon there is a side chain. 1, 2, 3, 4, 4th carbon there is a side chain, but it is made up of 2 bonds. So 1 bond is there, so give a carbon. Again there is another bond, give another carbon. Okay. And the last between the end carbon there is a double bond, give double bond here. Okay. Now count the valency and give the necessary hydrogen. So here it will be having again 3 hydrogens. So give the 3 hydrogen around it. Okay, so give 3 hydrogen around it. Here 2 bond is there, so 2 more hydrogen. Here 2 more hydrogen. Here 1 hydrogen. Here it will be having 2 more hydrogen. This is having 3 more hydrogen, and this again having 2 more hydrogen, and here there is 1 hydrogen, last 2. So its structure becomes CH3, CH2, CH2, CH, and on that there is C2H5 and CH double bond CH2. So this is how the structural formula for this bond line notation is.